Test is a formal procedure for using observed data to decide between two competing claims. They're called hypotheses. We have a little mnemonic device to write down all the different parts of a significance test, which we will get to later. Okay. Our conclusions, we either reject the null hypothesis or we fail to reject the null hypothesis. We never ever say that we accept H naught. That is always wrong. It's only one of these two conclusions. Also, just because we fail to reject H naught does not mean that it is true. Our result is based on a sample of data, and it's also possible to make mistakes, okay, which we will talk about today. So we have either one-sided or two-sided. And also it's important to note that in our hypotheses, we always have parameters. Either population mean or population proportion. All right, mu or p. Those are the two most common. It doesn't have to be those two, but for our purposes right now, we're going to deal with mu or p. All right. And let's see, I said hypotheses always refer to the population, not a sample. Always write the hypotheses in terms of the population parameters. Okay, so that brings us to this right here. It says Mike is an avid golfer who would like to improve his play. A friend suggests getting new clubs and lets Mike try out his 7-iron. Based on years of experience, Mike has established that the mean distance the ball travels when hit with his old 7-iron is mu is equal to 175 with a standard deviation of 15. He's hoping that his new club will cause the golf balls to go farther. State the appropriate hypotheses for performing a significance test and be sure to define the parameter of interest. Okay, so I'm going to define the parameter first. This would go, if we were going through the steps of Phantom, this would go in the first section with the P, with the parameters. So I'm going to say the parameter of interest is, what am I looking for? I'm looking for the true mean. Parameter of interest is the true mean distance in yards the balls travel when hit with the new 7-iron. Okay, so in this case, that would be mu, because I'm looking for the true mean. So my hypotheses. Mu equals 175 is my null hypothesis. Because, all right, they tell me this right here. Mike has established the mean distance the ball travels when hit with the old 7-iron is mu is equal to 175. So that's kind of what I'm making a comparison against. So mu equals 175 is my null hypothesis. My alternative would be mu is, and for the alternative, you need to look in the context of the problem. Mike thinks that the new club will cause the balls to go farther. Therefore, my alternative would be mu is greater than 175. And it is a one-sided test. So here's a quick little review from yesterday. The probability computed, assuming H naught is true, that the test statistic which mostly for our purposes, the test statistic is either going to be X bar or P hat. The probability computed H naught is true that the test statistic would take a value as extreme or more extreme than that actually observed. Okay, that is the definition of the p-value. So The smaller the p-value, the stronger the evidence is against H naught, because they say that the observed result is unlikely to occur when H naught is true. Okay, it's like my basketball example yesterday. If someone claims they're an 80% free throw shooter, and then in the test statistic, they get a result that they shot 64% in that sample, what is the probability of that happening? If that probability is less than 1%, it's very low, then that is evidence against H naught. Large p-values, on the other hand, fail to give convincing evidence against H naught in favor of the alternative, because they say that the observed result is likely to occur by chance when H naught is true. We always assume that H naught is true for these purposes. Okay, so if the p-value is low, we will reject the null hypothesis. And if the p-value is large, we shall fail to reject the null hypothesis. So 2 observations. It's always reject or fail to reject. And it is always in terms of the null hypothesis. Okay, and statistical significance. If the p-value is as small or smaller than alpha, we say that the data are statistically significant at that alpha level. And in that case, we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative. And significant, as we said yesterday, in the statistical sense, means simply not likely to happen by chance. Okay, and so just a quick little thing about how you choose a significance level. Many times you don't, it might be given to you, but you must decide how plausible is H naught. If H naught represents an assumption that the people you must convince have believed for years, then you need strong evidence, a very small p-value, in order to persuade them. Or perhaps you might consider, what are the consequences of rejecting H naught? If rejecting H naught in favor of an alternative means making an expensive change of some kind, then you will need strong evidence that the change will be beneficial. Okay, you're talking about golf. Well, in the grand scheme of things, that might not be as important as other things. Okay, users of statistics have often emphasized standard significance levels. Okay, so normally alpha is going to be something like 0.1 or 0.05 or 0.01. Kind of the default setting. If they don't give you one and say check it at this level, then I would just use alpha equals 0.05. So let's answer these 2 questions here. It says, what does significant at the 0.001 level mean? So in general, we want a p-value that is less than 0.05. Because the observed result is unlikely to occur by chance. So if my p-value is 0.001, the probability of having an outcome or a more extreme outcome or more extreme is 1 in 1,000. Which is not likely by chance. Okay, in general, we want to reject H0. Right? Because the whole reason that we're doing is that we are thinking that there is an alternative hypothesis. Okay. So if it is significant at the 0.001 level, that means it's unlikely to occur by chance. So my p-value, if it has a probability of that, then that means it would only occur in 1 out of 1,000 times. Okay, so the next question, it says, which alpha is more likely to reject the null hypothesis? Alpha equals 0.05, alpha equals 0.01, or alpha equals 0.001. So I want you okay, which alpha is more likely to reject? Okay, the answer to this, alpha equals 0.05 is more likely to reject. Why? Well, when do we reject H0? If the p-value is less than alpha. So if my p-value is less than 5%, if alpha is 0.05, then we would reject. Whereas if the p-value is less than 1%, we would reject if it's 0.001. And if it's less than 0.001, we would reject. So there's a greater, if you think about this in terms of a probability, there's a greater rejection region at 5% than at 1%, for example. Okay, so said alpha equals 0.05 is more likely to reject because the observed result is unlikely to occur by chance. So if my p-value sorry, no, I made a mistake there, sorry. If alpha is equal to 0.05, it's more likely to reject because let me fix that, sorry about that, the observed result is more likely to occur by chance. Sorry about that. Okay. If an event occurs less than 5 out of 100 times, we would reject. Whereas at 0.01, we would reject if it is less than 1 out of 100. And then 1 out of 1,000 at 0.001. Okay, so the higher your significance level, the more likely you are to reject. So turn the page. Let's look at this. So we wrote this down, mu equals 175, and then mu is greater than 175, or mu is the true mean distance in yards. Mike hits the golf ball. Based on 50 shots with the new 7-iron, the mean distance was 180 yards. And after checking that the conditions were met, we do a significance test and we get a p-value of 0.072. Explain what it would mean for the null hypothesis to be true in this setting. So in this setting, H naught mu equals 175 means the true mean distance with the new 7-iron is 175 yards. Okay, that's what it means for the null hypothesis to be true. And then this next part is important. Interpret the p-value in this context. And when we interpret the p-value, we are always assuming that the null hypothesis is true. So, assuming the mean distance is 175 yards, there is about a 0.072 probability. That's what the p-value is. There's about a 0.072 probability the sample mean would be 180 yards, because that was the sample result that I got, or it could be more extreme. So 180 yards or more. In a sample of 50 shots with the new club. So when we interpret the p-value, we say, assuming that the null hypothesis is true, which in the context of this question, the true mean distance is 175 yards. There's about whatever the p-value probability that we got, there's about that probability that the sample mean would be 180 yards or more in a sample of 50 people with the new 7-iron. And so what conclusion would we make for each of the following significance levels? All right. If alpha is 0.1, is my p-value less than or greater than alpha? It's less than. So therefore we would reject H naught. Okay. So because the p-value, which is 0.072, is less than alpha, which is 0.1, we reject H naught. And when I'm rejecting the fact that mu equals 175. Okay, and so this is your conclusion. Write it like this every time if we reject. So we say, so there is sufficient statistical evidence to conclude and then put it in context, the true mean distance traveled by the new 7-iron is greater than 175. So let me go back to my two hypotheses. Null hypothesis, mu equals 175. Alternative is that it is greater than 175. I have a p-value of 0.072, which is less than the significance level of 10%. Since it's less than alpha, we reject H naught. So we say there is sufficient statistical evidence to conclude that the true mean distance traveled is, and we put it in terms of the alternative, greater than 175. However, if alpha is 0.05, is my p-value less than alpha? Now, no, it is not. So we say, because my p-value, which is 0.072, is greater than alpha, which is 0.05, we fail to reject H naught. And so what's my conclusion here? You always need to write it like this. So if we reject, there is sufficient statistical evidence to conclude, and then put it in context of the alternative. If we fail to reject, we say there is not sufficient statistical evidence to conclude. So there is not sufficient statistical evidence to conclude the true mean distance is greater than 175. Is greater than 175. Okay, so now when we draw a conclusion, we hope our conclusion will be correct, but sometimes it will be wrong. So there are two types of mistakes that we can make. So if we reject H naught when H naught is true, we have committed we are pretty creative, so we call this a type 1 error. That is when you reject H naught when H naught is true. So we call this, I call this, it's my little catchphrase, reject the truth. Reject the truth is a type 1 error. If we fail to reject H naught when the alternative hypothesis is true, we have committed a type 2 error. Okay, and so my little catchphrase for this is believe a lie. So let me I want to be careful here because I don't want you to take away the impression that I am advocating any political or religious beliefs. Okay. But let me give you two examples that I hope will allow you to remember these. Because somebody a while back told me this and I was like, that's good. That makes sense. Okay. So reject the truth. This is like Jesus. So the adherents of Christianity said that Jesus was an innocent man. However, the Romans rejected that and they crucified him. So they said that he was guilty of blasphemy. However, they got it wrong and they killed an innocent person. Therefore, they rejected the truth that he was innocent and killed him. Okay? Well, type 2 error. This one is like OJ. Before your time, I know. Maybe you should watch the Netflix documentary, right? On the white Bronco, right? But this was before your time. But OJ, many people thought that he was guilty. However, the glove didn't fit, right? Therefore, the jury came back with the verdict that he was. No, we don't use that language. They came back with a verdict that he was not guilty. Therefore, the jury believed that he was not guilty when in reality, many people assumed that he was. So they believed a lie. Well,
you must have quit, coach.
Well, he was convicted in a civil suit, right? But not the criminal suit. So, type 1 error. When you reject a null hypothesis that is in reality true, the probability of making a type 1 error is alpha. This is the probability that we make a type 1 error. It's at alpha, whatever our significance level is set at. When you fail to reject a null hypothesis that is false, the probability of making a type 2 error, that is called beta. And we will talk about that a little later, okay? However, I want you to think through, what are the consequences of making a type 1 error? And what are the consequences of making a type 2 error? Well, the answer to that is, it depends. Which one is worse? That also depends. Okay, so what is worse? We imprison an innocent person? Well, if we've done that, right, we've made 2 mistakes. Not only have we put an innocent person in jail, but what? The guilty person has also gotten away free. So that could be bad, right? As opposed to the alternative. But think about this. Which is worse? The doctor tells you that you have a terminal cancer, but you really don't. Or the doctor tells you, hey, based on the lab results, everything is fine, but you really do have terminal cancer. Both of those have specific consequences, right? And the answer, and I see this question fairly often on the AP exam, but it all depends on the context. Which one is worse? What are the consequences of a type 1 error? What are the consequences of a type 2 error? Okay, it depends. So we're going to look at one example today and then be done. But tell you what, let's take a little stretch break first. So here's a little chart. We reject H naught when H naught is true. That is a type 1 error. And the probability of that is alpha. If we fail to reject H naught when H naught is true, that is the correct decision. And likewise over here with the type 2 error. So here's a specific example. Okay, the manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after their order is placed. Based on store records, the proportion of customers who had to wait longer than 2 minutes was P is equal to 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through times and test the following hypotheses. So the null hypothesis is that P is equal to 0.63. The alternative hypothesis is that P is less than 0.63. Why is it less than? Because we think that adding an additional employee will reduce the proportion of customers who have to wait more than 2 minutes. Where P is the true proportion of drive-through customers who have to wait longer than 2 minutes. And we're going to use the significance level of 0.05. Describe a type 1 error and a type 2 error in this setting and explain the consequences of each. So, a type 1 error would occur if the manager okay, what's a type 1 error again? What's my phrase? We reject the truth. Reject the truth, type 1. So a type 1 error would occur if the manager finds convincing evidence that the true proportion of drive-through customers who have to wait longer than 2 minutes has been reduced. I reject the null hypothesis in favor of the alternative. So the manager finds convincing evidence the true proportion of customers who wait longer than 2 minutes has been reduced. But it really has not been reduced. Okay, so if I make a type 1 error in this context, I believe I'm rejecting the null hypothesis, but the null hypothesis really is true. So I reject the fact that it is 0.63. So I believe that it has been reduced, but it really has not. So what is a consequence of that? I'm paying an extra employee money to reduce the wait time, but it is not effective. So a consequence is the manager will have to pay unnecessarily for an additional employee with no reduction. So a type 2 error would be, what's the phrase? We believe a lie. So a type 2 error would occur if the manager did not find convincing evidence the wait time had been reduced but it really had. Okay, and so a consequence would be we could have had better customer service but we did not achieve this because we thought that it was ineffective. So a consequence. The manager could have had service, but this was not achieved. And the last question here is, what is the probability of making a type 1 error? So probability type 1 is always equal to alpha. And so in this case, alpha was set at 5%. Therefore, that is the probability of a type 1 error. Questions for me?